Hello everyone, and thank you for joining us today here. So I will be giving an introductory talk to OpenWISP, where I will be sharing all the features and how you can use them to manage networking devices. So carrying on. So as who am I? I'm Gagan, and I work on OpenWISP full time as a core developer, where I wear multiple hats to collaborate with the community in developing this beautiful piece of software. And if you like cats, then after the talk, you can talk to me. I love cats. So what is OpenWISP, right? So whenever someone asks me, I just say, hey, OpenWISP is an open source network management software. But what is actually a network management software? So it is a software tool which allows users to actually manage. When I say manage, I say, okay, you have to configure a networking device, okay? And then you can also upgrade the firmware on the device remotely. And then you can also monitor the devices straight from the OpenWISP. And right now, we are primarily working on supporting managing OpenWRT devices, which OpenWRT is like an open source firmware, firmware for networking devices like routers, switches, etc. So what is the mission of OpenWISP? Why does OpenWISP exist, right? It exists to minimize the efforts and cost required to manage networking devices and to reduce the duplicity of efforts and to automate as much thing as we can. Because as we all know, humans are bad at doing the same thing over and over again. So why just not delegate it to the machines? So a little bit about history of OpenWISP. So it started as a project from universities in Italy, where they developed it to manage public Wi-Fi systems. Then it got adopted by municipalities in Italy, where they use it to manage public Wi-Fi system in real life, like which were being used by actual users. Then later on, it was from year 2015, it was rewritten in Python using and developed in Django. So earlier, the OpenWISP one, which was developed, which was used by the municipality in Italy, was built on Ruby. But now we have rewritten it in Python because it offers more flexibility in the development and to provide more generic configurations. So now we develop OpenWISP 2, and now it is being adopted by many more ISPs around the world and used by organizations to also manage their internal network. So I think most of us have already seen some kind of these devices, right? These are routers and access points. And generally, before I joined OpenWISP, my experience with routers was when I had to change the Wi-Fi password, when I had to change the SSID, that's it. But that's not only the tip of the iceberg here, right? There are so many configurations which are available on networking devices. So just giving you an example. Oh, wait, no, I did. Yeah. So, yeah, just giving you an example. Here, this is how you set up a Wi-Fi interface. Like, you turn on Wi-Fi on an OpenWRT device. This is very simple, straightforward, and you put in an SSID here. You put in an SSID here, and that's it, right? You put in some kind of Wi-Fi security, encryption, etc. But what do you have to do this over and over 300 access points? Like, this is not actually doable. So how does OpenWISP simplify these things for you? So first of all, we have a comprehensive dashboard where we will go all of these points in detail. So just to iterate over it, we have a comprehensive dashboard, and we also provide configuration management, templates, the concept of templates, variables, and groups, which we will dive in deep, and I will also show a demo about it. And then we also generate configurations which are compatible with different firmware versions, and so on. We also support VPN provisioning and many things. So this is a general dashboard of OpenWISP. So as you can see, there is a map on the top which allows users to actually see where the device has been deployed. So let's say if we have Wi-Fi router, Wi-Fi access points all over Hanoi. So we can actually see, okay, which part in the city the particular access point is deployed. And then below it, there is a few donut charts. So the first one shows how many devices are active and unreachable. So as you can see here, we have 140, in the screenshot, we have 143 devices which are online, and some of them are unreachable. The next one is the configuration status. So whenever you apply a configuration, you change the configuration on OpenWISP, it then applies it on the device. Sometimes the device may fail to apply that configuration, and we get a general overview that if there are many devices which are dealing with that problem. And the last one just shows the distribution about how many devices have been actually mapped on the map, and how many are not. So the last one just shows that. There are a couple more charts here. So the first one just shows the distribution. So there is the distribution of the devices on different parameters. First one is device model. It's very rare that if you have a big fleet of devices, you will always have just one model, because there are different requirements for different places. So we just give you an overview about different models, firmware versions, system type, which is like what is the chipset which is being used on the device, and then the active Wi-Fi session and the distribution of different groups. Then also we provide this general overview with time series graphs. So the first one is Wi-Fi clients. So how many devices, so how many people, how many devices, and when I say devices, I say mobile phones, laptops, how many are connected to the Wi-Fi system of the network, right? So we can actually get an overall idea that how many people are actually using the network. And then below it, we have the general traffic chart. So we can see how much traffic is going throughout the network. And this gives a good idea that how much a system is being used. So before we jumping ahead, I would like to share this thing about OpenWISP. We have this editor here, which allows users to set up configurations in OpenWISP. So this one, so here you can see it shows an example for the same example that we started with, right? It sets up a Wi-Fi interface, which can be used to access internet or everything, right? So this is, we provide two ways. This is the GUI. So you can just, this is a simple drop-down menu, and you can fill in details. And then we also provide for, the users who are, for advanced users, we provide advanced mode of configuration generator, which is like in JSON object. So you can define, we have a schema, you have to follow it, the user has to follow it, and then using that configuration in JSON format, we can actually generate the configuration for the device. And then we can do vice versa itself. So you can provide the configuration using the editor, and you can get the JSON, or you can provide the JSON, and the editor will automatically read it and show you in the UI format. So let me give you a quick demo of this. So here we have, the same example of editor. So you can see that if I want to add another interface here, I can just do add interface here, and it will gives me option to actually configure that interface. So not only Wi-Fi, like I have been stressing about on the Wi-Fi part, but just because like the normal users, that's the most common thing which they use with Wi-Fi for configuration of access points. But here we have more options as well. So not just interfaces, we can do configure different radios on the device, such as like the 5 gigahertz range or the 2.4 gigahertz range of radio. And we have different things, like you can set firewall itself. You can also configure VPN, and we will jump on that later on in the talk. And yeah, the advanced mode of the configuration generator. So as you can see, here we have different we have of the same configuration which I added. So if I change, let's say, something here. So let's remove this interface which I added for the demo right now. So if I remove this, and let's just remove everything, right? So the configuration editor reads it and it removes everything. So basically it provides two ways to generate this configuration. And it also provides, if I will just refresh it to save time, right? And it also provides a way to actually see the configuration which will be generated on the device. So here, if you are not familiar with the OpenWrt syntax, I will not bore you with that, but it just says that create this interface, and then this is the configuration for the actual Wi-Fi, and it is not using encryption right now. So yeah, that's pretty much it. Moving on to the next part, which is templates. So right now we have been talking about just configuring one device, but if you have to do it over and over again, we have the concept of templates, which reduces the concept of duplicity of efforts and also code. So what is a template? They are reusable. Configuration. You can apply multiple templates on a device. So let's say we will have an example where so on my device, you can see that there are these are the templates in OpenWISP. So you have two templates applied. One is the SSH keys. So the server's public SSH key will be applied on my device. So the server can easily authenticate, log in using the SSH service. And the second one is the configuration, which I just showed you before. It is that template which has been already applied, right? So I can just add more templates as well, such as I will just add this one, and I can also add the template for WireGuard, etc. And then you must have seen in the example, like I added this VPN configuration for 0-tier and WireGuard, right? So we have an option here. So the type of the template, there are basically two types of templates. One is generic, the other one is VPN client. So the generic templates are used when you have to change anything else, like anything on the device, and you would usually use the VPN client template type when you are applying some configuration specific to a VPN, which is managed by OpenWISP. So if you want to connect it to some external VPN service, you can just use the generic one and put the configuration yourself. But if it is managed by OpenWISP, OpenWISP will automatically generate the template based on the type of VPN server you are used. So yeah, this is the example, and as I have already shared, so we have few different things: the name, the organization, and the type of the template as I shared, and the backend of. So right now, as I already shared, that we support OpenWRT, but in future the project has been developed in a way that in future we can extend it and support other firmwares as well. Yeah, small thing. There are two small things here. First one is enabled by default and another one is required at the bottom. So enable, if you flag a template as enabled by default, so any new device which registers on the system, it will automatically have the template enabled. So it reduces the amount of effort that you will need, the amount of effort you will need to put to set up a new device. You can flag some devices, some templates which are enabled by default, and then it will have the template. Whenever a new device registers, it will have that template. And if you flag a template as required by default, required, then the user won't have an option to remove the template. In the example, we had time for internet to not work. Well, actually, we will just move on with the presentation, and maybe if it starts working, then I will just show you after that. We also have the concept of variables. So let's say you have this template and you have created it for everyone, right? But my access point does not need the specific value. Which one common thing which we have observed in deploying systems is that the MTU has to be configured based on the underlying on the VPN based on the underlying networking technology. Like if you are using LTE network, you have to set a lower value of MTU, and then if you have a good reliable fiber network, you can use a higher MTU. So we have the concept of configuration variables, which allows users to customize only specific parts of the template. So you will have a big configuration which is reusable in general, but a part of it can be customized. Then we have the concept of groups. So as I shared earlier, that a big, like any network will have devices which are of different categories, of different models. They have different drivers, etc. So let's say you can create groups for two type of devices. One is routers and other is access points. So you basically do not want the configuration of routers applied on your access points. So you can create groups for this, and then you can add the specific template to a group, and you just apply a device to a group, and all the configuration which has been applied on the group level will automatically apply on the device as well. And we have it will work just like you have applied if you apply individual templates on the device, but it just reduces efforts. So here I have this group, and as I will just go through this with you. So similar to the device page, you can apply as many templates as you like here. So I will just add this one, right? And you can also provide configuration variables directly at the group level. So you can say some device will need, some family of devices will need some specific value. So you can also provide it here, and it will get applied to all of the devices that are present there. Yeah, so I touched the concept of that we also allow provisioning VPNs earlier. So we currently support three VPNs, managing three VPNs. One is OpenVPN, Zero Tier, and WireGuard. So OpenWISP will, so with WireGuard and Zero Tier, OpenWISP will also manage the server side of the deployment. So it will, so if for WireGuard it will generate encryption keys, etc. For it will generate the certificate file and private keys for OpenVPN, and for Zero Tier it uses a proprietary hash key for connection. So it will also generate that. Yeah. So this we have been talking about this. We have been talking about what goes on the server side, what goes on the controller side. Now we will talk about what happens on a device and what is actually needed on the networking device. So we have an OpenWrt package called OpenWISP config. This package is installed on the networking device, and it communicates with the OpenWISP server, and then it applies the configuration which is generated by the server. It constantly polls the server to see if there is a configuration change. It can also accept push configurations where the server pushes the configuration that there has been change and you need to apply this. Then it has a very neat function that it tests whether the new configuration works perfectly or not, causes any errors or not. Let's say due to some human error, there is a modification in the template, in the configuration created on OpenWISP, which is not supported by this particular device. So the agent will test the configuration. If it finds any error, if it runs into any error, it will just roll back those configuration change, and then it will report it to OpenWISP that, hey, there was an error applying this configuration, and it would also provide some error log lines which can help to debug the problem which is occurring on this device, right? And then it has some hot plugs, which is like concept of OpenWrt. It is like servers. It is like signals and receivers. So whenever we provide some hot plugs, like what happens when the configurations get reloaded? What happens when the configuration has been successfully applied? So this provides customizability to the system, where users, based on their own needs, can write script which are executed at a particular operation of applying configuration. And then it also collects some basic data from the device. As we saw on the charts, right? We saw that there was information about the firmware, the model, and the system SoC. So this OpenWISP config agent sends that information to the OpenWISP. And then this is not only like, you can not only configure OpenWISP config on the device using the SSH, using terminal, but you can also install the Lucy web app, which is the web GUI of OpenWrt. And then just like you will use any web application, you can configure OpenWISP config agent. But the best part of OpenWISP configuration agent is that you can create a new firmware, you can have everything on there which is required to register the device on the system, which is like the URL of OpenWISP, and there is a secret which is used to register the device on the system. You have a firmware, you create a firmware, you flash it on all the device, and just when you switch on the device and plug it to the internet, it will automatically register the device to OpenWISP, and then it will start behaving the way you want. Now we also provide support for executing shell commands on device. So from the web UI itself, you can execute some commands directly on the device. So you can use these commands here. So we provided some basic commands which are just like you click on it and it will work, like reboot, change password. Maybe you want to just check whether the router has access to some specific to the internet or some specific web address, you can use ping or trace route to diagnose the network, which is becomes pretty handy when you are managing different devices. Then you also have the option to execute custom commands. So anything that you could execute on the terminal using SSH, you can execute it here. And during the start of this during the start in the dashboard, we saw a map. So and the map gets generated when the user puts the location of the device in OpenWISP. We also provide the support for for mobile devices. Let's say an access point is deployed on a bus, and the bus moves across the city. So if using a script on the network device on the access point, we can send updated coordinates to OpenWISP, and it will reflect on the map. And we also I think any network management software will be incomplete without support for provisioning and assigning subnets and IPs. So we do provide a way, and we use it to work with zero-tier and WireGuard VPN, where we control how many subnets and how many IPs each device would get. But it can be used it is pretty extensible and pretty customizable. You can use it any way you want. Okay, we have been talking about configuring the device. You have changed the configuration on the device on the OpenWISP. How would we know whether those configuration gets applied or not, and whether a device is online or unreachable, or a device is experiencing some kind of issues, like is it under load, is it running out of memory, is it running out of storage, etc. So that functionality is also built in OpenWISP. So as I was saying, we can see the status of the device, and then the system metrics like CPU, disk usage, and storage. And it also checks for reachability. It does a ping check. So we would know, okay, the device is reachable by OpenWISP. And it also has its separate OpenWRT package, which is called OpenWISP monitoring, and we will discuss about it later on. So this is the device status page. Here, as you can see, we are seeing the load average on device, and the amount of RAM which is being used by the system, and some other things like storage as well. Apart from this, we also provide a way to see this information on time series graph. So the first one you are seeing is the ping. And the device is, OpenWISP is configured to check for the reachability of device at every 5-minute intervals. So, and the chart is being plotted that way only. You can also change the the time span of the chart, so you can see older data as well. Like, okay, in the last 1 month, tell me when was this device experiencing a problem. Below it, you can see the round trip time. So this is actually useful for diagnosing networks. It will just show how much time that ping checks incurred, how much time was incurred in the round trip of the ping checks. And the third is the CPU usage. We plot it in time series chart, so we can know the duration of the metric. Now there are also network devices which supports placing a SIM card in them, and then you can actually, there are travel routers, travel modems right now, modems and routers. You put in a SIM card in them, and then you will start using them as a hotspot. So for those kind of devices, you can actually get metrics for the signal quality and for signal strength. And this is the Wi-Fi session tracking thing. So whenever a my mobile phone will connect to the Wi-Fi of any of the managed device, it will create a session with the information it received from that particular mobile phone or laptop or any other thing. So this, as I already shared, this helps to see how much the network is being used by people. Yeah, and this we also provide configurable alerts. So whenever, let's say, you want to know, you just don't want to see that your device is having 100% of CPU usage all the time. We also want to know when it happened, right? So we also send alerts which are customizable by the user. So you can set it, okay, if the device experiences more than 90% CPU usage for 10 minutes straight, then you can only send me alert but only send me an alert at that time. But if it, the CPU usage spiked just for a minute and then it settles down into the normal range, then the user need not be required to be alerted, because this creates a lot of spam in the inbox, and the user deals with alert fatigue, where they will actually ignore the alerts which were actually important. So as similar to the config agent, which deals with the configuration of the device, we have the monitoring agent of OpenWISP, which is OpenWISP monitoring. It is installed as a separate package on the OpenWRT, and it provides a way to collect the metrics directly on the device. So metrics for CPU usage, RAM usage, memory usage, storage, traffic, etc. It collects that information and uploads it reliably to OpenWISP. So in case, let's say, there was a network outage for some time, the monitoring agent will still collect the information during that time, and as soon as it gets network connectivity to OpenWISP, it will then also send the old data. We also have active monitoring checks. So these are the checks which are performed on the OpenWISP server. So it will perform ping checks. So the server will check for reachability of the device at the configured amount of time. Then it will also check whether the configuration generated by the controller was successfully applied on the device. If a configuration fails for any reason, it will just alert the user about the particular device. And we also provide tests for using iPerf3. This is useful to know the bandwidth of the link between the OpenWISP server and the device. But you can also customize it to run the iPerf3 check against an external system, external iPerf3 server, which will provide you information, okay, what is the actual bandwidth to the internet of this device. Yeah, so we have covered configuration generation and monitoring. The next thing is firmware upgrades. As we all know, all of us are dealing with tech here, right? And tech evolves, software changes, and the scary thing with this firmwares, and that you stay outdated. You get outdated, and then it will get outdated, and you will expose it to vulnerabilities, etc. So we do provide a way to share firmware upgrades to upgrade the device remotely using OpenWISP. You will just there are few different concepts. One is build. So you will just upload the firmware image here, and then you will apply the image to the device, and you just click on save, and then OpenWISP will handle the firmware upgrade process. It will push the file on the device, and it will upgrade the device, right? OpenWISP also provide a way to check the network topology, right? So here you can see that the links in the green are the devices which are have working links between them, and the red ones are the links are not working. So the network topology provides way to collect topology data, and then you can visualize it, and you can also go back in time to know when was a particular link was not working. So the last thing about in this is the radius part, which is the public Wi-Fi systems, right? So we have integration with free radius for to support working with captive portals. So which allows user to sign in and then access the network, and also for WPA enterprise, where you put your you do not have a particular captive portal, you just put the credential directly on your device when you select this particular type of, when you connect to a Wi-Fi interface which support this particular type of encryption. Then it is also possible for users to, do a self sign up. So some jurisdictions do not want to allow people to randomly access the internet, without any identification for security purposes. So they can use SMS to have to know what is the who is accessing the system. And then we also support social login OAuth 2, and it also supports SAML, so you can also integrate single sign-on on those service. And we also have a paid module, which will only allow access to the network after a subscription. So yeah, we have this separate React page, React app, which generates the Wi-Fi login pages. It acts as a front end for the Wi-Fi service. So this is the registration page. If this organization requires mobile phone numbers, it will use it. If it does not, it will not show that. And then it will verify using SMS. And only after that the user will be able to use the service. So these are the screenshots of the Wi-Fi login pages app. It just you can, as discussed before, it also allows to sign in using OAuth 2. Social logins, and then it will show the status, whether you are accessing the internet. It will also show how much traffic you have used, and it will also send an email to the user that they have a new Wi-Fi session for their account has started. So this is the SAML login, and this is the paid subscription module, which will only allow access to the system when the user makes a transaction there. So basically, the user will just fill in their details, and they will be prompted to make a payment, and then it will allow them to access the network. So here in this service, they are using PayPal to do the payment, and after this, they will be greeted with, they will be able to access the internet. Yeah, so as we have been discussing that it provides, OpenWISP provides modularity and extensibility. Users can configure it. Users can you customize it to their liking, and then they can use the system as they want. We provide REST APIs. This is a holistic architecture which you can also provide on our website. I think the time is running out and we will not be able to discuss it. And you can deploy it using Ansible role. Yeah, so we generally support OpenWRT here. And everything which OpenWRT supports will be can be managed by OpenWISP. Yeah, So thank you very much for your time.